All right, this is Math 2413 Cal 1, Section 3.8. And what's cool about 3.8, it's another great method that Newton came up with for approximating the zero of a function. Can somebody tell me what the zero of a function? What's another word for zero of a function? What is a zero? Any anybody tell me what's a zero? When I say what's a zero of that function, what's another name for it? What do you call a zero? It's, I mean, if you're going to find a zero, it's good to know what a zero is. Anybody? Come on now. It's not an asymptote. That's a good guess. A root. Uh, I have there's an algebra word. I think you can call them roots also. I'd rather call them x-intercepts. Thank you, Yvette. They're actually the x-intercepts. They're the x-intercepts of the function. They're the x-intercepts. We call them zeros. You know, here's my graph. Let's just say I'm going to show you a graph. This is a zero and this is a zero. They're x-intercepts. They call them zeros because on x-intercepts, y equals 0. Do you see this? Let's call that coordinate 0, 0. And this coordinate x is 5, y is 0. They call them zeros because y equals 0 for all x-intercepts. So zeros and x-intercepts mean the same thing. Okay, so you're looking for the x-intercepts. Where does your graph cross the x-axis? That's what a zero is. And we're going to use this formula, so you better have this formula written down when you take a quiz or a test. And let me explain this formula a little bit. This is, I'd like to call this a guess. So I'm going to start with x of n, a good guess. And then we have the function and then its derivative, the function and then its derivative. So we guess and then we subtract the function divided by its derivative. And then Newton came up with this, and it's a pretty cool thing. It's a pretty cool thing. Later on, we're going to talk, if we haven't done it already, I can't even remember, Newton's approximation for square roots. I don't think we've done that yet. But he uses a very similar method to approximate the square root of 24 or the square root of 17. Without a calculator, he can get really, really close. But they're called approximations, not exact answers. So I don't want the exact answer. I want Newton's approximation. So we have to use this formula. Okay. And I think we're going to do two of them today. So here's the first one. Wait, this is not the first one. Give me a second. Is this? Yeah, this is the first one. So we want to approximate the x-intercepts or the zeros of this function. Can somebody right now tell me what the zero is without using a calculator or anything else? What is the zero of this function? You should be able to tell me. Everybody should be able to tell me what the zero of this function is.
+2.
Good guess, but that's wrong. It's okay. I want you to be wrong because you can't learn unless you make this mistake. 2 is a good guess, but it's wrong. I know that sounds harsh to me. It's not 1, Paul. Good guess. Well, I don't know if that's a good guess, Paul. Am I picking on you guys today? I got a really good night's sleep. Anybody else? Come on. What's the zero? This is an algebra problem. Okay, let me show you what the 0 is. Wait.
Is it square root 2?
That's it. There we go. Who said that?
I
Who
did.
said that? Yeah, I don't know who I is.
Yvette.
I I can't. I'm sorry. I can't see anything. I
Yvette.
don't. Yvette. Okay, thanks. Okay, so it is the square root of 2. Look, remember, this is just as the same function. I already said a 0 is when y equals 2, y equals 0. Take the 2 to the other side, square root both sides. X equals plus or minus the square root of 2. So there's two zeros here. There are two zeros in this problem, plus 2 and minus 2. If you look at the graph, right? I mean, if you look at this graph, this is what the graph looks like. It goes through the square root of -2 right here on the x-axis. Here it goes through the square root of 2. That's, I mean, it's a parabola, and it goes down to 2 here, but the square root of 2 x-axis and y-axis here. The square root of 2, if you put it on your calculator, what is it, 1.41? Square root of 2. I'm sorry. Now I just messed up my calculator. I am just pushing everything wrong. Exactly. 1.41, 1.4142. Okay, so just remember that. But we're going to use Newton's method. Newton didn't have a calculator to put the square root of 2 in his calculator. So Newton devised this method, do an approximation pretty close to it. You notice we have a function, and then we have the derivative of its function. Here's the function. Here's its derivative. The derivative of x squared minus 2 is 2x. So we have our two functions here, the function and its derivative. Okay, so what I already said, this first x of n is a good guess. And I'm going to guess what the book shows on this. Well, somebody said 1. So, I mean, even if you guess way off, we already said the square root of 2 is about 1.4. A good guess would have been 1.5, but I'm not going to use that. I'm going to use 1. Let's say I'm a very bad guess. I'm a very bad guesser. So if I'm a very bad guesser, uh, my guess, I'm going to put right here, don't forget, this is my guess. At first, I'm going to put 1. By the way, this is one iteration. There's the word. They want us to do this 3 times, 2 iterations, 3 iterations. They want to go through this process 3 times, okay? That's what the book asks us to do 3 iterations. In reality, you could do 5 or 6 iterations going through the whole process. So first, x of n equals 1. We're going to plug 1 into the function. That's our x, our first x. So we're going to plug 1 into the x value of our function. 1 squared minus 2 equals -1. So we get a -1 right here. When we plug 1 into this function, we get 1. Then I want to plug 1 into its derivative. Here's the derivative. F prime of 1, 2 times 1, and you get 2. Okay, so here's what happens when I plug 1 into the function. Here's what happens when I plug 1 into its derivative. And then it says divide the 2. -1 divided by -2 is -0.5. And then it says subtract. X of n, my x of n was 1. And then I'm going to subtract whatever I got right here. Do you see? I got a -0.5, which this equals 1.5. So on my first iteration, I end up with 1.5. Remember, we know the answer already. It was just because we know the answer. We had a calculator. It was 1.4142. So we're close already. Do you see the first iteration that Newton does is pretty close. So this is my new guess. Down here, I'm putting 1.5. Do you see my new guess? I'm putting 1.5 as my new guess for the second iteration. So that means I'm going to get closer to the 1.4 because now I'm closer as a guess. So I put 1.5. I should have made it a little bit bigger so I could have did this. I'm going to now put 1.5 into here. Do you see we're putting 1.5 into the first function, and on my calculator, 1.5 squared minus 1, or minus 2, sorry, and I get 0.25. So in the first function, I get 0.25. When I put 1.5 into the derivative, I get 3. You see, now I'm putting 1.5 now into the function. I'm putting 1.5 into the derivative, and I get 3. Then I do the top function, 0.25, divided by 3. Do you see the top function divided by the derivative function? And then I get the x of n, which is 1.5. That's my new x of n, minus 0.25 divided by 3. I'm just going to write it in there, 0.25 divided by 3. So on my calculator, 1.5 minus 0.25 divided by 3. And on my calculator, I get 1.4166. I'm going to go 4 decimal places, 67. That rounds to 1.4167. So we're closer. Do you see how close we are? Our calculator said the derivative, the square root of 2 equals 1.4142. We're closer now. So that's my new guess. And this is our third iteration. They only wanted us to do 3 iterations here, 1.41. 6, 7. So I'm only going to take it to 4 decimal places. So everybody following me? Does it look pretty simple? It's pretty, you're just plugging the stuff in. Everybody okay? I know I'm just rambling without asking anything.
Yes, sir. It looks simple for right now.
Yeah, you're just plugging it in and doing the work there. So now we're plugging 1.41. I'm going to put that whole decimal in here. 1.4167 squared minus 2. So 1.41, oh, I have it on my calculator already, squared minus 2. And when I put that in my calculator, I hope somebody's checking my work. I get 0.069 but I'm just going to take it here. And then when I do that too, and I put that whole 1.4167 into my calculator here, 2 times 1.4167, I get 2.8334. If I divide the 2, and I'm going to check the book to see if I got it right. I'm going to do 1.4167 minus this 0.0069 over 2.8334. So I'm going to put 0.0069. That's 0.0069. First, I got to do the first. 1.4167 minus 0.0069 divided by 2.8334. And on my calculator, I get 1.41426. And my calculator matches that to 4 decimal places, 1.4142. So that, I mean, 3 iterations, I get, this is just an approximation by Newton. This is not the exact answer. Newton approximated the square root of 2 using that, finding the zeros of this function, and it just so happens by approximating the square root of 2, using this, I mean, exact to 4 decimal places without using a calculator. That's pretty cool, I think. I mean, look at that. We didn't do anything that we couldn't do by hand if we didn't have a calculator. Newton didn't have a calculator, and look what he did. Sounds like a good deal. I'm not sure when the slide rule was invented. Maybe Newton had a slide rule. Okay, so that's it. That's the calculate 3 iterations. We just did that to approximate the 0, and it's 1.4142. I mean, I could have rounded to 43, but that's pretty good. I'm impressed with Newton. I think it's cool. All right, any questions on this one? We got one more to do. That's it. One more to do. It's a little harder. It's not a little harder. It's just, it's the same thing. Just want to make sure everybody's okay with this. Do you see this X of n at first is a guess? So you can guess anything you want. I could have guessed 5, and then eventually, eventually I would have got to 1.4142, but it might have took 1 or 2 extra integrations. If you guess the wrong number, it's okay. It might have took more iterations to get there. In the homework, they may tell you do 3 iterations, or work this out until you can't get the right answer anymore. And I'm going to show you that on the next problem. Do you see, if I did, I just to show you, if I did, I'm not going to do it, but if I did a 4th iteration, I'd have to put 1.4142 here, or even 4.3. I'm going to put 4.2 here. If you do the iteration and you end up with 1.4142 again, that's when you know you've done it as many iterations as you possibly can, because you're always going to get the same answer then. Do you see? That's when you know you're really close to the approximation and you've got it to 4 decimal places. So you know you're done if you do another iteration and you get the same answer at the end as you did in the previous iteration. That's when you know you're done. So if I would have guessed 5 at the very beginning, oh, I think the 0 is at 5. I mean, that would have been a really bad guess. But if I would have put 5 here, you see, it might have took me 1 or 2 more iterations, but eventually I would get down to 1.4142. And we're going to show that, I think, in this next problem. And I'm going to try to follow the book just so we look at this. This is a tough one to guess at first. Once again, it says do 3 iterations. 1, 2, 3. We're going to do 3 iterations. We need to guess at first. Now, if I'm gonna do something that I mean, it's fine to do this for this class, but Newton couldn't do this. Let's put that function in our calculator. Y equals e to the raised to the x power plus x. So I just put it in our calculator, y equals e to the x power. Yeah, y equals e to the x power plus x. And make sure the plus x comes down. It's not in the exponent area. And when I graph it, my graph should be negative 10, 10. When I graph it, you should be able to see the x-intercept. Can somebody tell me approximately where the x-intercept is? If anybody's following along on a calculator or look at my calculator, it's kind of hard to see because I'm not making it bigger. I don't have my other camera set up. Anybody know where it's at, the zero, the x-intercept? It's definitely a negative. Do you see that it's going to be a negative value? And somebody's typing something in. Negative 0.5. That's exactly what I would say, Paul. About negative 1/2. However, the book doesn't want me to do that, so I'm not gonna use negative 0.5. The book wants me to use negative 0.6. So I mean, if I was doing this, I would do negative 0.5. Just let you know, Paul. That's exactly what I would do. So my first guess is negative 0.6 because the book wants me to. I want to follow the book and just make sure I have the same answers as the book. But if I was doing this problem on a test, I would have put negative 0.5 down. You could put, by the way, you could have put any number down. You could have put -1. You could have put 0. You could have put 1. You could have put 28. The 28 would have been a way off answer. But you want to get as close as you could. So negative 0.6, that's fine. And you know the answer is going to be negative because E is 2.7 something, 2.7 to some power plus X. This is positive. This is always going to be positive if you raise it to a power. So the x value has to be negative for them to cancel out and turn to 0 somehow. So you know the answer would be negative in some form, the x value. I don't know where. I think maybe as a great guess, I would have put -1. But negative 0.6 is fine. So let's put negative 0.6 in this function. E to the x plus 1, and I'm going to change the color and put negative 0.6 into this function. On my calculator, E to the negative 0.6 plus 1. When I put it into the function, I get 1.5488. By the way, we haven't taken the derivative of this yet, but the derivative of e to the x is e to the x, and the derivative of x is 1. So here's the derivative. Derivative of e to the x is e to the x, and the derivative of x is 1. So we got 1.454. Wait a minute. That's not what I got. Did I write down the problem down wrong? Oh, did I? Oh, nobody saw what I did wrong. X is negative 0.6. There should be a negative. I need to make sure X goes in here and in here. That's definitely the wrong answer. I say there's no way I came up with that answer. So let's try that again. E. I was looking at the derivative when I was plugging it in. You have to plug it into the original function. E to the negative 0.6 and then minus 0.6. And this is what I get, negative 0.0512. If I round it to 4 decimal places, this is what I would get. Then I'm going to plug it into its derivative. Its derivative is E, oh, that's not good. e to the negative 0.6 plus 1. There we go. There's the derivative. I was using the derivative for the first one. E to the negative 0.6 plus 1. And I get the 1.54. 88. And they take, by the way, the book takes it to 5 decimal places. So in the homework, you might want to take it to 5 decimal places since the book, 5 decimal. They're in the homework, they're taking it to 5 decimal. They'll probably tell you, but type your answer to 5 decimal places or 4 decimal places. So there's the 5th decimal, and the other one was 5119. 5119. So then we divide these two, negative 0.051119. I think it's just 5119. Yeah, 2 ones and a 9. Divided by 1.54881. So whatever we get when we divide these two, I'm going to erase that, but just show you we divided those two. Negative 0.0519 divided by 1.54881. And I have an extra 1 in there. And when I do that, I get negative 0.03305. I take my original xn, negative 0.6, and I subtract this negative 0.003. 0.03305. Come on. And when I put that into my calculator, I get negative 0.56695. 0.56695. Negative 0.56695. So once again, this is the answer I got at the end. This is my new guess. And we do the same thing. I'm going to put that number in here, negative 0.56695. I'm also going to put it right here, negative 0.5665. And when I put that into the function, second E, negative 0.56695, bring it down to the bottom, minus 0.56695. Oh, Lord, I get this really small number. Move the decimal 4 places. I get, it's a positive 0.0003 and 3 0 if I take it 5 decimal places. If I put it into the, by the way, calculator gives it scientific notation. This is a 1, so this is always going to stay 1. So I'm going to do the same thing for the derivative, second EE, negative 0.56695, plus 1, and I get 1.56725. I'm just checking this to make sure I get the same numbers. And then when I divide these two, right here, when I divide these two, It says I get 0.00019. 0.00019. And that's a positive. Then when I take my original xn, negative 0.56695 minus 0.00019, I get a negative 0.56714. That's my third guess, negative 0.56714. And I want to show you when I plug this back into here, I actually, and when I plug that back into there, I actually get 0. When I plug this one in, I get 1.5 674. When I divide the two, by the way, you get 0. Do you see? This is the amount of change. We're not changing anything. So if we have the original and we don't change anything, we're right back where we began, 56714. Do you see? Once you get 2 iterations with the last number the same, you don't have to do any more iterations because you're always going to get the same number. You're done. You found the approximation as close you can here to 5 decimal places. I mean, you could have took this out 8 or 9 or 10 decimal places if you're crazy. But do you see, for 5 decimal places, we got the same number in the third iteration. So you don't have to do it. We're done. So in a homework, if they say find the answer, you have to go until you do the next iteration and get the same number as the previous. That's when you know you're done. So many people ask me, how do I know when to do these iterations when I'm done? As soon as you get at the end the same answer as the previous iteration, you are done. Okay. And that's it. Any questions on that? I mean, it's just pretty much plug and play here. You're just plugging things in. It tells you the steps. The hardest part people always forget is, what is x of n? Well, at first, it's a good guess. You want to get an approximation to the 0 as close as you can. And then you just take this guess and you put it into the function. You take this guess and you put it into the derivative. So you have to find the derivative of the function. Derivative of e to the x is e to the x, derivative of x is 1. You find this answer, you find this answer, you divide these two, you get this answer, and then you add it or you subtract it from your guess. And if you end up with a negative, then negative changes to a positive. And then you keep on going until you have 2 successive iterations at the end that equal each other. All right.